This is a video on initial speed and maximal height. The question states, a projectile is fired with an initial angle of 20 degrees from the horizontal in order to hit a target at ground level 400 meters away. Find the initial speed the projectile should be fired and find its maximal height. So we will assume that the only force acting on this projectile is gravity. And in that case, the acceleration is negative 9.8 times j. I use negative 9.8 because we're using the units of meters. We're given that the projectile is fired with an initial angle of 20 degrees from the horizontal. That helps us with our initial velocity. We don't know the magnitude of the velocity because that's the speed of the projectile, which is the question. So we set out that the initial velocity is speed times the cosine of 20 degrees. That's like r times cosine of theta in polar coordinates for the x-coordinate, and then times I plus v naught times sine of 20 degrees times j. We're also given that we're firing this projectile pretty much from home, so we can say that the initial position is just 0. We want to hit the target, which is 400 meters away at ground level. Ground level means that the j component is 0, and the I component must be 400 if we're going to hit the target. We can say the position function, r of t final, is 400i. So let's get the velocity from the acceleration by integrating, so that v of t is the integral of a of t dt, and the integral of negative 9.8j is a constant times I plus negative 9.8t plus a constant all times j. So we can find those constants by plugging in 0, so that v sub x is v naught cosine of 20, and v sub y is v naught sine of 20. So that gives us our velocity function in terms of time. If I want my position function, I can integrate again. So the position function r of t is the integral of v of t dt. The integral of v naught cosine of 20 is just v naught cosine of 20t plus a constant, and the integral of negative 9.8t plus v naught sine of 20 is negative 4.9t squared plus v naught sine of 20t plus some constant. But I'm given that r of 0 is 0, so if I plug in 0 for t, I'm just left with the two constants, so those constants are both 0. So now I plug in t final, and I'm supposed to get 400i. So that means that for the first component, v naught cosine of 20 times t final is equal to 400. And for the second component, there's a 0j for r of t final. So that tells us that negative 4.9 t final squared plus v naught sine of 20 times t final is 0. So I have two equations and two unknowns, and I solve. And what I did is I just divided by v naught cosine of 20. I plugged in the 400 over v naught cosine of 20 in for t final, and that gave me a quadratic, and I used a calculator, and I got that v naught was about equal to 78 meters per second. And that's my initial velocity, which is the speed that I need to fire the projectile at initially. Now I just need to find the maximal height. But when we're at the maximal height, the j component of the velocity will be 0, because that means it goes up and then it goes down. So I can plug in t maximal and get 0. So I can say that negative 9.8 times t maximal plus v naught, which is 78, times a sine of 20 degrees is equal to 0. And I can solve this by subtracting 78 sine of 20 and dividing by negative 9.8. And I got that T maximal was about equal to 2.72 seconds. So now I just want to find out what the maximal height is, and I can plug in this T maximal into the J component of the position function to get that maximal height. So I say that Y maximal, or the maximal height, is equal to negative 4.9 times 2.72 squared plus 78 times sine of 20 degrees times 2.72, and I plugged that in my calculator, and I got about 36.3 feet. So I can conclude that we should fire the projectile with an initial velocity or an initial speed of 78 meters per second, and I will reach a maximal height of 36.3 feet. And I'm done with the problem.